So I've said this multiple times in other videos, and then I changed my mind in the part of the video and say, well, there's another one, there's another one. But this is the final example for this lesson for logs and exponentials, and then we're done with logs and exponentials for a little bit, and then we'll come back to it later on as a review, and then we'll do other stuff. So here's the last example, another word problem, but here's actually a word problem with natural log in it, or logs in it. Natural logs, really. So here, again, if you want to stop it and then write it down, then you can do that. Or if you just want to go ahead and just go with me through it, it's fine, either way. So you can stop it now. Okay, so as you've already written it down, it says, talking about the growth of environmental industry, of the environmental industry. All right, so the formula N equals 461.87 plus 299.4 natural log X models the thousands of workers N. So N is the thousands of numbers of workers. And let me go ahead and highlight that part too. So N is the thousands. Let me highlight it actually. Highlight it. So N is the thousand of workers. And then so N is the thousand of workers in the environmental industry in the United States. And X is the years after. X years after 1979. And the important thing is after 1979. So if it's if X is 1, that means that's going to be 1980 that we're talking about, the year we're talking about. So here we're trying to figure out by which year will there be 1.5 million or 1,500,000 1,500,000s of U.S. workers in the environmental industry. So here they give us the formula, and we're going to use that formula here. Oops. There we go. Ooh, extra 9. My fault. All right, so we put that in there. Now we're trying to find how many years it would take to get to the 1.5 million or 1,500,000 of U.S. workers. So what I'm going to do is since we're talking about N is in thousands, so I'm going to use this part here because it says thousands of workers, so we're using 1,500 thousands workers. So I'm going to put 1,500 here, and we're going to figure out what N is. Not N, sorry, X. What X is, my fault. We're going to figure out what X is. And so we're going to use our rules for natural logs to be able to, or logs, to solve this out. So we're going to condense it if we can condense it, isolate, and do all the great stuff, and then solve it out. And this one we're not going to check, so we don't have to worry about checking it. So we know this is our natural log part here. So it means we need to get that 461.87 to the other side. And go ahead and put that in the calculator and find that decimal number there. So 1,500 minus 461.87. And that gives us, hopefully everybody got 1,038.13. Some of you are like, wait, Mr. Hall, you said not to put in the calculator until the very end, blah, blah, blah. This one, you're not dividing. This one, you're just subtracting. So the numbers, you're not rounding any numbers. You're keeping as it is. Now, if you divide, sometimes when you divide, it's like gets really big, long numbers, long decimal numbers. And if you try to round those, it's going to be wrong. It's going to mess you up. All right, so again, here, we're trying to get X by itself. So we need to get the natural log by itself. So we're going to divide by that, this part here. Yeah, I feel like I've left off a number with that 4. Probably didn't, but let's check out. Let's make sure. No, we're good. We're good. All right, so we get that 299.4 to cancel out. So we're left with just natural log here. Natural log. And again, I would keep this all together because you're dividing now, so I can give you this really long decimal here. And again, if you round that decimal, it's going to change your answer, your final answer. So we're not going to do that. All right, and then how do we get rid of the natural log here? And hopefully everybody remembers you have to use the e to get rid of natural log. So we're going to make e the base number, and we're going to make these exponents some really big exponents. But again, that's the only way we can get rid of our natural log here. So we're left with just an x. Right? So the e's cancel out, e and the natural log cancel out. So we're left with x equals all this wonderful information here. And again, if there's any point here that you get lost or not sure why we did something, stop the video and call me over. Don't just keep going and be like, well, I just get it later on, I guess. It'll make sense later on, I hope. And then when it gets later on, it doesn't make sense at all. All right, so we're going to put this into the calculator. And again, we're going to do second ln to get the e. And when we go up to the exponent part, we're going to do alpha y equals and enter to get the fraction, and we're going to put the fraction in. And then once we put it in, we hit enter. And here, everybody should have got approximately about 32.052, just around 3 decimal places. And then again, we can't have like a point something of a year. So let's just say 32 years. So that's what x is. But are we done with the problem? Are we done with the problem? No, we is not done with this problem. Because it said that x is the number of years after 1979. Yes, year my brother was born. Hey, that's cool. So it says x is 32 years, but that's the number of years after 1979. So it says, what year will it be that we will have 1,500,000 of workers, or 1.5 million? So we got to make sure we do that last part. So we know 1979, because x is the years after 1979. So here, we're going to add 32 to that number so we can figure out how many years after 1979 it will be. So here that's 11. We take that up there. That's 10 plus 1 is 11. So that gives you a 0 because it's a 10. So about 2011 is when they said that we should get 1.5 million in the environmental industry. Which I'm not really sure if that happened or not. I really don't know. But you can always look that up. Woo. Alright, so I'm writing this out in a sentence form because we must have a sentence. Alright, so we have this part, 2011, and that's it. We're done. We got it. We got it going. Alright, so again, if there's any questions on this, stop the video, stop me, call me over and make sure you understand what's going on before you just keep moving on. Alright, so that is the end of this lesson. That's the last word problem, and I'm just going to give you homework, and then we're done.